Got to give the people what they want. We're going to do 5.1 factoring trig expressions. Try to do this thing quick. Get this up for you guys. So first off, just write this stuff down. Factoring trig expressions. So this is all built off of stuff that we've done before. So first, this is built off of factoring. And you might remember, always find a GCF if possible. If you can, factor it. After that, if you got two terms, look for a difference of squareds. A squared minus b squared, or a to the fourth minus b to the fourth, because fourth is just a perfect square of a squared, okay? And we're going to talk about this. We've done this before. If you have three terms, you're going to organize them in standard form, so in order of the exponents, and then use the area model if you see the pattern below, right? If you see something with an x squared, then an x to the first, then a constant, you're going to factor it using the area model, the box method. Or if you see something with an x to the fourth, then an x to the squared, then a constant, you're going to try to factor it using the area model. And finally, if you see that you have four terms, you're going to try factoring by grouping, right? So four terms is when you have something like 5x plus 9x minus 6x minus 8, right? It has 1, 2, 3, 4 terms, okay? So remember, that's when you put together the first term and the second term. This is not factorable by grouping, but I'm just telling you. That's when you put together the first term and the second term, and then you group together the third term and the fourth term, and you look for GCF here and see if you have a GCF here, okay? And then you see what are you left over with. Do you have a common factor left in both parentheses? I'm not going super deep into these because we've done this. We did this months ago, all right? Now we're just doing it with trig functions, so it's really not different. So let's do a couple of examples. Ooh, boom, boom, boom. Okay, so let's do this first one. It says sine x cosine squared x minus sine of x, okay? So let me go through. First thing it says is find a GCF if possible, so let's see. This has sine and cosine squared, and this one has sine, so their GCF would be sine. So I'm going to factor sine x out, and I'm left with cosine squared x minus 1, because remember, sine x times cosine squared x is the sine cosine squared x minus sine x times negative 1 is negative sine x. All right, so that's just a reminder. We're just factoring out a GCF, which you've done a whole bunch of times before. And now I'm looking at this and I'm like, ooh, okay, I think I could simplify that. That looks like that comes from that Pythagorean identity. So I know that sine x squared plus cosine squared x equals 1. But this says cosine x minus 1. So let me see, how can I do this? So if I do minus 1 here and minus 1 here, I end up with sine x squared plus cosine squared x minus 1 equals 0. And now if I move this over, sine x squared minus sine x squared, I end up with cosine squared x minus 1 equals negative sine x squared. So this, which is the same as this, actually is equal to that. So really what I have is sine x, this piece, times this piece, which instead of calling it cosine squared x minus 1, I'm going to call it negative sine x squared, right? And that's just a negative 1 sine x squared. So this whole thing, sine x to the first times negative 1 sine x to the third, becomes negative 1 sine x to the third power. And there is my final answer. All right, let's do number 2. 2 says secant squared, I forgot to write the x, excuse me. So 2 says secant squared x secant squared x minus 1. All right, so my first step says look for a GCF. There is not a GCF. Excuse me, I'm going to take a driggity drink right here. My second thing says if there are two terms, right? This has 2 terms, so that's looking good. Look for a difference of squares, a squared minus b squared, or a difference of fourths, a to the fourth minus b to the fourth. Well, this is a squared, secant squared, and 1 is a square because 1 squared is 1, or the square root of 1 is 1. The square root of secant squared is secant. So both of those are perfect squares. So if I remember correctly, I'm going to do a plus b times a minus b. And remember, a and b are the square roots of the secant squared. So in this case, a is secant, which is the square root of secant squared, and b is 1 because b is the square root of 1. So this becomes secant x plus 1, a plus b, times secant x minus 1. And I have now factored it. Secant x plus 1 times secant x minus 1. And just for fun, to make sure you remember, right, to prove that this is right, if I wanted to multiply these, secant x plus 1, secant x minus 1. Remember, secant times secant is secant squared x. Secant times 1 is secant x, 1 secant x. Secant times negative 1 is negative 1 secant x, and negative 1 times negative 1 is negative 1. So I end up with, and this is just the check to remind you how this works, secant squared x, 1 minus 1, these two cancel out, minus 1. Boom, boom, that's my check. You don't have to do the check, but that's just a reminder because we haven't looked at it for a while. All right, let's go on. Number 3. It says 4 tangent x squared, or excuse me, 4 tangent squared x plus tangent x minus 3. All right, so I'm looking at this one. There are no GCFs. This does not have 2 terms. It has 1, 2, 3 terms. So let's go back to our notes. 3 terms. Organize it in standard form and use the area model if I see the pattern. I see the x squared, I see the x to the first, and I see a constant. Let's see. There's the tangent squared, there's the tangent to the first, and there is the constant. All right, bet. Let's use the area model. So let's go ahead and set this up. So this is basically like instead of, this is basically, we're going to call this whole thing x squared. We'll consider this x. We're just taking the tangent out of it. And this is minus 3. So this is really like 4x squared plus x minus 3. Okay? That's all we're doing. We're factoring it like it said that. We just basically took the tangent part out of it. Right? So if I was going to factor 4x squared plus x minus 3, I'd be like, oh, I got this, Bass. We did this for years. All right. Oops, excuse me. 4x squared. I know this is the minus 3. I know blank plus blank has to equal 1, right? It has to equal the middle term. And I know blank times blank has to equal negative 12. Because remember, it's the diagonals. You multiply them. These diagonals are equal to these diagonals. Again, I'm going through this fast because we've done this before. All right, we're going to use this. So they got to multiply to negative 12. And they have to, I need 2 numbers that add to 1, multiply to negative 12. What's that, 3 and 4? 3 times 4. Boom. Okay. So negative 3 times 4 is negative 12. Negative 3 plus 4 is 1. So we have 3x, negative 3x and 4x. Now we're going to factor these things. All right, so what are we going to do? We're probably going to do 4 and 1 here. So 4x, 1x, minus 3 plus 1, negative 3 times 1 is negative 3. Yep, we're looking pretty good. All right, so if we factor this, we end up with 4x minus 3 times x plus 1. Again, that's just old school factoring. Now all we have to look at is, what did we actually substitute for x? Well, we said x is actually tangent of x. So I'm just going to replace x with tangent of x. 4 tangent of x minus 3 times tangent of x plus 1. I factored it, right? I just substituted x back to tangent of x because it makes it a little cleaner and easier for us to write. Bang, bang, bang. All right, let's do our second to last one. All right, I'm looking at this. I'm like, does it have, go ahead, write this down, 2 cosecant to the 4th x minus 7 cosecant squared x plus 6. Why don't you try to do that one before me? It's almost the exact same idea as last time. So cool, hopefully you tried it, but if not, we're going to look at it here. No GCF, it doesn't have 2 terms. It does have 3 terms though, 1, 2, 3. And I'm looking at that 3 terms, and I'm looking at that format. It's not x squared x1 constant. This is an x to the 4th, x to the 2 constant. But we're going to do the exact same thing. So let's bust this thing out. Just like before, I'm going to call this my x squared term. I'm going to call this my x term. So this is basically, I'm going to factor this like 2x squared minus 7x plus 6. All right? Stick with me. Why don't you factor that? I know for sure you know how to do that. So cool. You factored it and you were like, Bass, this is nothing. I got this. So let's see. 2x squared, that's a 6. Blank plus blank has to equal negative 7. Blank times blank has to equal 2 times 6, which is 12. Okay. Multiply to 12 and add to negative 7. Negative 3, negative 4. Positive 12, negative 7. Negative 3x, negative 4x. The 2 has to go here. The 1 has to go here. That's minus 3. This is minus 2. Negative 3 times negative 2 is positive 6. I'm looking good. So I end up with 2x minus 3 times x minus 2. All right. But remember, what did we say x is actually equal to? X was equal to cosecant squared x. So I'm just going to say 2, and in place of x, I'm going to put cosecant squared x minus 3. And in place of this x right here, I'm just going to put cosecant squared x, and then I have minus 2. I have factored it. It worked. Boom, boom, boom. All right, last one. Boom, boom, number 5. Write this one down. Yeah. Tangent cubed x minus tangent squared x minus tangent x plus 1. Okay, let's go through. Does it have a GCF? No, because this is 1, so it can't have a GCF. Are there 2 terms? No. Are there 3 terms? No. Are there 4 terms? Yes. 1 term, 2 terms, 3 terms, 4 terms. So what did it tell me to do when there are 4 terms? Bang, bang, bang. Factor by grouping. Can I find a GCF of the first 2 terms and then a GCF of the second 2 terms? So let's see. Let me go ahead and group these. Yak, 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 yak. Yak, 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 yak. Okay. So tangent cubed minus tangent squared. What can I take out of both of those? I can take tangent squared out. And I'm left with tangent squared times tangent, times tangent x minus 1. That should look good, because if I multiply this, that would give me tangent cubed. If I multiply this, that will give me negative 1 tangent squared. Just as a recap. Okay? Well, can I factor these? Is there anything that I could take out of these? Well, this is negative 1 tangent plus 1. I could divide out a negative 1. So if I factor out a negative 1, I end up with, oh, look at this. Tangent x and 1 divided by negative 1 is minus 1. Oh, snap! Look, tangent x minus 1. Tangent x minus 1. So I'm going to take that. We did this factoring by grouping, so this should be coming back. Oh, yeah, I remember that. Tangent x minus 1 times, I just take this one and this one. And I put them together. So times tangent squared x minus 1. And I have officially factored number 5. That's it, Mr. Bass. I'm out. Psych. Nah, I'm out now.